Hello viewers, welcome back to Dexter's Tech Lab. So in my last update video I mentioned there's a couple of things that you might be interested in seeing. I gave you the choice to see what you wanted to take a look at, and a couple of people mentioned they wanted to see this, the DVT SmartImage Sensor. So we're going to have a look at that today. But before we get started, I want to thank PCBWay for sponsoring this channel. PCBWay manufacture PCBs, obviously, but they also do a lot of other stuff as well. They've got a great community of community design projects that you can just click and buy, and they'll make and send it to you. If you're interested in making projects yourself, PCBs, electronics, that kind of thing, go and check out PCBWay. They've got so much to offer, and they've been fantastic supporting this channel. So thanks very much to them. I also want to thank my loyal patrons for their continued support. Without my patrons and PCBWay, I wouldn't be here making these videos for you to watch. A number of years ago, I actually picked one of these cameras up off eBay. I didn't know what it was, but it was just cheap. I think it was like £20 or something, and it just looked interesting. So I went ahead and bought it, got it into the lab, started playing around, doing some Googling, and then started to realise that it was actually quite an interesting thing. This was sort of before the days of me making videos and things like that, so having a little discussion about it on the EV blog forum. And from there, I discovered a few people had worked with them. I also discovered that the software to drive them is all still available, and I did get that camera up and running. I picked as I said, I picked one up for, I think it was about £20 or something like that, and I actually noticed that they were selling for, you know, $250, $300 on eBay. I went, I'm not going to keep this. I'm just going to flip it and make a few quid in the process. Sold it on, and they've always been of interest to me. So I started looking again not too long ago, and these cameras have now come down even more. And you can regularly pick these up for you know, £50 or so. So because the price has dropped, I picked up another one. I also picked up this interface unit, which I didn't have before. It's just a convenient way to plug everything together. Now, this specific camera I purchased in America. Actually, had it shipped to the UK. This one seems to have come from a General Motors car factory. Setup that I found on it looked like it was looking at a particular body panel on a particular car. So in an automated production facility, you might have things that come on conveyor belts or move about or get sorted automatically, and that's what these cameras are typically used for. There is a whole suite of functions that you can do with these cameras, and you can combine them together, and the net result is it gives you a pass-fail status. So for example, you might have say a conveyor belt, and there's a box which has got some bits in. It doesn't really matter what it is. What you could do with this camera is have it set up so it can see something coming into view. You could program it to say, is a blob of this particular shape located here, this shape located here, and this one here. If it is, if they're all there, then it passes. If it doesn't, it fails. The outputs from these cameras can then go off to other parts of the automation system. So, for example, a tray that came in that was missing a part, it could be rejected by the conveyor belt system and dealt with by a human. Now, there's all sorts of other things that you can do with these cameras. You can take measurements, you can do barcode reading, OCR, lots and lots of different things, and you can combine them all together. Now, the more things you combine into the program, the slower the camera gets. You can certainly start to see, when I show you this working, how it could be used to automate very dull and repetitive operations. So let's take a look at the actual camera itself. The main connection is here on the back. It's actually a 15-pin sub-D, which is the same as VGA. So we've got 3 ports on the back. We have an RJ45, that is Ethernet. We have this port here, which is, I think that has some very, very basic I/O on it, as in GPIO. and we have the main port which carries most of the signals, including power, through the VGA cable to this box. This is known as isolated Bob. It's a breakout box, so it just allows you to take the camera's GPIO and break it out to various connections. So looking further around, we've got a sticker there that says United Sales and Services Inc. Camera number 2, right fender. IP address 192.168.0.244. So this would have been connected up with an Ethernet cable. So the actual box itself is quite it's a very solid lump of stuff. It's obviously built to last. It's very, very hard, chunky bit of plastic. The lens on the front is a standard C-mount lens, and you can see in there the CCD, and there is a little adapter thing mounted on there that can be removed, and in fact actually the CCD is actually attached to that. It sort of unplugs from the boards that are inside. The difficult issue that I've got here is you can't seem to be able to take the box to bits. I suspect there's 2 circuit boards inside, one on this side and one there. They seem to have been put in and then the whole thing's been glued together. So I'm not actually able to do a teardown properly on this. I can remove the CCD and you can have a quick peek inside, and you can see the 2 circuit boards, but from what I can tell there is no way to get this back open, which is rather odd. I've never really had that before. I've not been able to find any sort of hidden screws, and the box just seems to be one homogeneous lump of plastic, so that's really odd. Depending on your setup, you'd have different types of lenses. You know, if you couldn't get very close to the thing that you wanted to look at, then you'd probably need a zoom lens, all that sort of stuff. So typically these would be set up and installed and then bolted in place. There would probably be also some very specific lighting that would have been set up as part of the camera rig as well, just so you can get the lighting absolutely perfect. It's one of the key things to actually getting these working reliably is lighting. It has to be absolutely spot on. When I bought this camera, there was also this cover which fits over the front of the actual lens. It just screws on with 4 hex bolts and just provides a little bit of a protective window in front of the actual lens. 4 status LEDs. We've got ready, trigger, pass and fail. So ready is just a light that comes on to say that the camera is ready and operational. Trigger is an external input which arms the camera effectively. Now that could be, if you went back to the example that I had about the tray with bits in on a conveyor belt, it might be that when the tray actually reaches its position, it would trigger something that would activate the camera. The camera would then look at it and make a decision, and then would issue a pass or a fail, depending on what it saw. So while that's booting up, I'll explain how these the software appears to work. There is a piece of software that runs on Windows XP, which is called DVT Framework, and it's basically a construction program that allows you to generate the code that gets loaded into the actual camera. All of the software is actually built on your PC and then it's flashed into the unit. So there we can see that it's booted up and it's ready and the fail light is on. I can't remember what program I had on this, but it probably, yeah, there probably will be some points that it's things it's looking at and it's making a pass fail. Okay, so we've got the DVT Framework software up and running. So what we need to do now is connect to the camera. Now I plugged it in on my network, so let's just connect to the camera. Now this window allows us to do that. There's different ways to connect to it. You can either use the serial port, which it has on one of the other connections, I can't remember where. We can search on the network, and there are also emulators as well. So this is a way for you to build a framework without actually having a camera there plugged in. So they offer emulators for some of their products. So what we're going to do is just go onto Network Neighborhood, and it will search for the camera, and now it's found it. I've already renamed it and made it easy to find. So that is on IP address 192.168.10.53, and it's running framework version 261, which is what the software is I'm running. So let's just connect to that. These are the different sensors that we have available. We've got edge counters and intensity, feature counts, so that would count number of features that it could see in an image. We could do math tools, so we can take measurements based on various things. We've got barcode readers, blob tools. That's where it looks for a particular shape, and various other different things. So we can see we've got one soft sensor already loaded, and it's called Edge Counter. So what we need to do now is turn on the real-time feedback. So this is actually a live video feed from the actual camera. If I put my hand in front, you can see there. You can see it's looking up against the side of my Quantel paint box. Down here we have a graph showing the intensities of the image. We've got the edge counter condition. It's failed. Edges equals 0. Alter the exposure time. We'll be able to brighten up the image and get a bit of a better idea. So yeah, you can see that. And you can see it's updating quite slowly, but this is coming over Ethernet, and you can see it's starting to sense the condition which is on this edge counter, which is this blue line here. So this can actually be picked up and moved about into different areas. So from this you'd be able to build up a certain pattern of various things that the camera is looking at to be able to make up a decision on whether a particular condition is true or false. So in this case we've got an edge counter, so this line is actually counting the number of edges that it can see. And you can see here on my intensity graph we have the number of edges, so this can actually all be altered in real time to get a more reliable reading from the camera. So we can change the trigger levels, that kind of thing. So if the trigger was up here, the condition would always fail because it's not in the right range of the intensities for it to actually be a trigger. Now if I move the camera around, these will move with it. So the threshold is this bar here that I was just manually adjusting. We've got types of edges, so we can go either dark to bright, bright to dark, and that kind of thing. So this is options to say, you can put conditions in to say it passes or fails, but you can also have warnings as well. So that might flag up to maybe some automation control software to say that the lighting is a bit marginal, it needs to be looked at, but it's not actually failing to read the actual image properly. So there's various things that you could set up to help your life. So the pass conditions here are actually minimum edges needs to be 1, so it needs to see at least 1 edge. So if I move this off anywhere that's got an edge, we will now see that it's gone onto the fail. So if I bring it back, it then passes again and tells us the number of edges is 8. So one of the first ones we're going to look at is rotation. So what this will do, you define an area on the image, and the camera will work out the angle of a line going through that area. So this could be used for making sure something's aligned properly in whatever situation it's in. You know, to go on to the next step in the production process, whatever it is, you might need to check, or it needs to be at least 45 degrees. This particular thing. So there's things like that you can do. So I'll just demonstrate that one now. So what I'm going to do is just define an area on the screen. Now at the moment it's just looking at the side of my Contel paint box. So what we need to do is put something a little bit more what it's expecting. So if I place this into the actual camera, let's put it that way. Now if we try and set up some of the thresholds a little bit, I think it's kind of getting it anyway, to be honest. Let's just turn the exposure time down a little bit. So you can see there that the red line is the actual angle of this this line that's running through the parallelogram. So the output value there, you can see it changing on the screen as I rotate it around. Now it is actually remarkably accurate. You know, you can get some, it goes down to 2 decimal places in resolution. So I guess the more of the camera is looking at a particular thing, you know, the more of the camera's sensor area you're using, probably the accuracy would go up most likely. So if this was only based, say, on a tiny portion of the camera sensor, then the accuracy would probably drop. The actual resolution of this camera, I think it's 640 by 480. I'm not 100% on that though, but certainly the later cameras they're now HD. So what they'd be able to do is probably quite remarkable. So that is measuring an angle. You see there, the contrast is starting to go, so it's starting to lose the line a little bit. So going down the list here, we've got intensity. So that you would define an area of the screen, and the intensity of the image would have to be at a certain value in that area. So it's just another way to say that there might be something there, but it's not very specific. Edge count, you saw that at the beginning. It simply counts the number of edges that it sees in a particular defined area. Feature count is kind of a little bit like edge count, but it's less specific. So it just looks for areas of contrast, and they have to be, or you can define them to be particular sizes, you know, number of pixels that the feature is. Measure across horizontal vertical lines. So let's just try this one. So let's just define a line. We'll give it a name, test. So minimum distance, let's say it has to be 20 pixels. Let's see what that gets us. So what I've done, I've just drawn a blob on bit paper, and we'll just see what. There you go. So it's detecting the black area, and it's working that out to 83.84 pixels. So as it's moving around, it's obviously changing. So that can count the number of pixels. So if you actually looked at this, you could actually calibrate it. So the number of pixels, because this would all be fixed in a rig, you could calibrate this, and you would know that if it's they're saying 58 pixels, if it was 58 pixels, you know that it's a particular actual physical size. So you can make sure that something's of a particular size, things like that. So we also have barcode readers. So this particular one can do data matrix, OCR, standard one-dimensional barcodes, and that's pretty much it. Yeah, so it's basically either data matrix, a traditional barcode, or OCR. So let's try a barcode. There we go. I'll get it in camera a little bit better. There you go. Probably needs a little bit of tweaking. You can see how important it would be to get lighting and position and all that sort of stuff. One of the other ones we've got is a blob, so we can actually check to see if there's a blob. A very, very simple detection of things in a rectangle. So if I go back to my piece of paper with the square in it, I bring that in, there you go, that's just detected that as one blob. And now we have 2 blobs. So the next one to look at is called template match. Now what I'm going to do is just set up the area that we want to look at. So now that's set up, if I move the bit of paper around, so the bit that's learnt matches the bit on the paper, we get an error. So if I move that now out of the bit that it's actually looking for, you can see where the two intersect, which means that it has to be the right shape and position in the frame. So the more that lines up, the less the error is. You can see there, max segment error, 13%. So if I move that completely out, the error is up there, 100%. The closer and closer it gets, the error drops. So that's just another test to look for a particular shape. Object find, so this is actually going to be more of an active search for a particular shape. So let's just define the search window. So this is all set up now. It's now learnt the actual object. So if I click that off, as I move this bit of paper around now, you can see that it's actually tracking the location of it. Yeah, so you can see there it's tracking the object, telling you where it's located and the angle that the object is actually at. So that's quite a cool one to do. You can see how the number of samples is slowing down now. It's having to do more and more processing to work out everything. Now obviously you can build up these programs and actually have multiple things, and you can have conditions, you can have a script, and the results can then be sent out to various parts of the camera. So you've got those GPIO outputs, so if you wanted to, literally just needed a switch output, then you could do that, or you've got the Ethernet possibility as well. So things could get logged in databases. You could talk to other parts of the automation system through over Ethernet. I could only imagine what the modern cameras are like. They must be really quite seriously advanced. And of course, because this software supports the other cameras, as I said, this is quite an old camera. The other cameras are higher resolution, they're colour, faster most likely. So there is actually colour tools in here as well. SmartLink, I'm not sure what that is. And you have some scripting stuff as well. And you've got a lot of different settings and configuration things that you can do with the camera just to set it up absolutely perfectly to get the image as good as it possibly can be, so then the camera can always make a decision. Now all of these things can get rolled up into the software that gets loaded into the camera. You can actually have multiple different settings in the camera if there's enough space for it. So what you could potentially do is have a production line which maybe one day it's set up for doing one thing and the next day it's set up for doing something else. So you could actually go in and actually have multiple profiles set into the camera, which you can then just switch to this product or switch to another product. So there we are. This pretty much wraps up the video on the DVT SmartImage Sensor 630. So yeah, fascinating bit of kit. As I said, when I picked up one of these a few years ago, it was like, wow, I didn't realise you could actually just buy a tiny little camera like this that could do all this image processing. So I just want to thank again to my patrons for their support, PCBWay for sponsoring the channel. Thank you so much. If you've got any comments or questions about this, then leave those in the comments, of course. I'll try and answer them as best I can. So that just leaves me to say thank you very much for watching. If you enjoyed this one, give it a big thumbs up, and I will see you on the next video. Bye for now.